Assalamualaikum and hi to our parents. My name is Muhammad Hafiz Fadli by Muhammad EFFENDI and my metric number is 52089. Today I will present to you about my final year project that entitled Distribution and Morphological Structure of SERGESTIDE Stream DECAPODA SERGESTIDAE from SEBERANG, TAKIR, TERENGGANU and BINTULU, SARAWAK. For introduction, the stream is belong to the family SERGESTIDAE and the order DECAPOD. From this family, there are two subfamilies. They are SERGESTIDAE, Luciferinae. The stream occur in surface water from 0 to 5 meter in massive swamp or accumulation, which is greatly influenced by the precipitation, wind, and tidal current. The stream also occur widely at the west coast of Peninsular Malaysia and locally known as Udang Baring, Bubur Udang Siring, and Udang Gerangau. Although represent with small number of species, but become one of the important economic resources in Asian and African waters. For the problem statement, the study on SERGESTIDE stream is limited due they are seasonal stream. The research on SERGESTIDE stream at Sarawak and Terengganu more emphasis on the aspect of PCR population structure, species composition, spawning season, land weight and land length relationship. The aim of the study is to discover the distribution of the SERGESTIDE stream species in the sampling site and to provide new information and data as a reference to researcher and Department of Fisheries. The objective of the study are to study the distribution of the species from Seberang, Takir, Terengganu and Bintulu, Sarawak, and to determine the morphology of SERGESTIDE stream from the different study area. For methodology, the sampling were conducted at Seberang, Takir, Terengganu and Bintulu, Sarawak. This area was chosen because of the abundance of SERGESTIDE stream occur in this area. There are three flows of the method. First is sample collection. The sample from Seberang, Takir, Terengganu was collected on 11 March 2020 by using circle net and push net with the help of the local fishermen. At the same time, some sample was collected from Bintulu coastal water, which helping of the fishermen from the area. The sample were placed in sealed plastic bag to deter from damage. The fresh sample were preserved with 10% of formalin immediately after collection. For the sample sorting, 1 kg of sample were used from each sampling area. Of 250 grams of sample were taken randomly and sorted in the sorting tray. From 250 grams of the sample, a total of 500 individuals with complete body from each station were selected for species identification. For the species identification, the measurement of total length and weight were recorded as additional data. All samples were measured using the diameter toyo caliper and weight using analytical balance to get the accurate scale of the sample. The identification of SERGESTIDE species was referred to the work and study by Omori, Amin, Won, Zafar, and Bikram. For the results and discussion, the figures show the distribution percentage of SERGESTIDE species at Seberang, Takir, Terengganu and Bintulu, Sarawak. For the figure 1, the highest percentage of SERGESTIDE stream was recorded by SERGESTIDE intermediates with 52% and followed by SERGESTIDE indicas with the percentage of 42.6%. Next, followed by SERGESTIDE japonicus with the percentage of 5.2% and lastly by SERGESTIDE solitarius with the percentage of 0.2%. For figure 3.2, the SERGESTIDE intermediates was observed as the highest distribution percentage with 57.4% and the second highest distribution is followed by SERGESTIDE indicus with percentage of 36.6% and SERGESTIDE japonicus with the percentage of 5.4% at third place. Similar like the observation at Seberang, Takir, Terengganu, the SERGESTIDE solitarius was recorded with the lowest percentage distribution at Bintulu, Sarawak with the percentage of 0.6%. The table 3.1 show the morphological structure of SERGESTIDE species from Seberang, Takir, Terengganu, and table 3.2 show the morphological structure of SERGESTIDE species from Bintulu, Sarawak. The apex of the taxon, SERGESTIDE intermediates, is the apex of the taxon is sharply pointed and the Archaeopteryx indicus, the apex of the taxon is almost triangular but different with Archaeopteryx intermedius. For Archaeopteryx japonicus, the apex of the taxon is usually rounded but it is truncate in few specimens. For Archaeopteryx cerulatus, the apex of the taxon are truncate. Discussion: in this study, 4 species that have been identified was lower than the number of species identified from previous study at both stations. In SEBERANG TERENGGANU, show only 1 species identified from the previous study, that was Archaeopteryx intermedius. Moreover, the Archaeopteryx indicus, Archaeopteryx japonicus, and Archaeopteryx cerulatus was first time recorded from SEBERANG TERENGGANU. Based on the previous study, only 2 species of Archaeopteryx shrimp been identified at Bintulu, Sarawak, that were Archaeopteryx intermedius and Archaeopteryx indicus. At the same time, the Archaeopteryx japonicus and Archaeopteryx cerulatus also first time recorded from Bintulu, Sarawak. For the conclusion, a total of 4 species from the Archaeopteryx shrimp were discovered, namely Archaeopteryx intermedius, Archaeopteryx indicus, Archaeopteryx japonicus, and Archaeopteryx cerulatus. These species were collected on March for both of the sample from SEBERANG TERENGGANU and Bintulu, Sarawak, where the season of Archaeopteryx shrimp to migrate. From the distribution percentage recorded, the dominated species is from species Archaeopteryx intermedius, followed by Archaeopteryx indicus, then Archaeopteryx japonicus, and the lower distribution percentage was species Archaeopteryx cerulatus in both stations. The changes of seasonal might influence in distribution of Archaeopteryx shrimp for both stations. For suggestion, samples should be kept in short period of storage time, though of long period can cause error to the measurement because the body tissue was degraded and made the maize not same such as the fresh one. Other than that, a sensitive weight balance should be used for weighing the samples to make sure the data was not wrong. These are for the reference. Thank you for watching.